Section 2.0.0, using personal protective equipment to reduce the risk of injury. So describe how personal protective equipment reduces the risk of injury, identify OSHA requirements for electrical personal protective equipment, and describe how to select and use personal protective equipment. Performance task, your instructor is going to ask you to select and use personal protective equipment. Might have you put on a hard hat, safety glasses, and gloves, or he might have you don a safety harness. PPE is the last line of defense against injury and exposure to electrical work hazards. Some of the most common personal protective equipment used on electrical jobs include rubber insulating gloves and sleeves, arc-resistant clothing, safety glasses and shields, safety shoes and overshoes, and hard hats. Before selecting what personal protective equipment to use, it's important for you to complete a task hazard analysis. Performing a task hazard analysis involves working closely with health and safety personnel to review all of the tasks and related hazards associated with a job. Basically, I think we talked about this before. You're going to look at a job before it is even started and try to make a scenario where anything that can go wrong does. Figure out what can possibly go wrong and then try to mitigate it. Try to use substitution or elimination or engineering controls in order to mitigate those hazards. Ultimately, performing a task hazard analysis may result in making changes to equipment, processes, or systems. It may also involve using specific personal protective equipment to protect you from a hazard. So here's leather protectors worn over rubber gloves. Sometimes personal protective equipment needs protecting itself. Here this guy is wearing rubber gloves, and if he were to use those rubber gloves harshly, if he's going to use a wrench and apply any kind of pressure or turning force to that wrench, he's probably going to put a big tear in the rubber glove. So he's wearing leather gauntlets over the rubber glove. And these leather gauntlets protect the glove from physical harm. So sometimes we have to protect our protection, if that makes sense. 2.1.0 OSHA requirements for protective equipment. OSHA has a number of standards related to the use of personal protective equipment on electrical jobs. Some of OSHA's primary standards related to electrical safety and personal protective equipment are included in the following sections. 2.1.1 PPE and Electrical Hazards. The employer shall provide, he has no choice in it, provide training to each employee who is required by this section to use PPE. Each such employee shall be trained to know at least the following: when the personal protective equipment is necessary, what personal protective equipment is necessary, how to properly put on, remove, adjust, and wear personal protective equipment, the limitations of the personal protective equipment, the proper care, maintenance, useful life, and disposal of the personal protective equipment. Note when you see the letters CFR, then you know you're looking at OSHA regulations, Code of Federal Regulations. Code of Federal Regulations 1910.137A lists the design requirements for electrical protective equipment. Code of Federal Regulations 1910.335 presents personal protective equipment safeguards for working on jobs where there are potentials for electrical hazards. And they'll tell you there's an entry limit, there's a close approach limit. There are different limits to how close you can get to the work at hand if it's electrified. Let's see, I don't see what these say here. Okay. So employees working in an area with potential electrical hazards shall be provided with the appropriate protective gear as stated in CFR 1910.335A1I. This gear shall also be maintained and inspected as required by CFR 1910.137 and 335A1 II. Personal hearing protection equipment shall be provided and used when sound levels exceed the levels shown in 1910.95B. It's 90 decibels for an 8-hour workday. If it's higher than 90 decibels for an 8-hour workday, you have to wear hearing protection. If the installation of protective equipment can be damaged during use, the insulating material shall be protected as required by 1910-335A13. So that's what they were saying. You have to wear over the rubber gloves. You wear these leather gauntlets to protect the rubber gloves from damage. Protection for the eyes and face shall be worn when there's danger of injury from electric arcs, flashes, or flying objects from electrical explosions. And 5, the hard hat. Non-conductive head protection shall be worn when there's a danger of electric shock or burns to the head due to contact with exposed, energized parts, as stated in CFR 1910-335A1-4. So we have to have a fiberglass or plastic hard hat that does not conduct electricity with a full face shield, and usually that full face shield is tinted yellow and it blocks UV rays, which can harm your sight, your vision. Tools that are insulated up to 1,000 volts shall be used when working near exposed energized conductors or circuit parts. Use non-conductive ropes and headlines near exposed energized parts. And use protective shields, protective barriers, or insulating material to protect from shock, burns, or other electrically related injuries when near exposed energized parts. Okay. Always use non-conductive ropes and hand lines near exposed energized parts. Use protective shields, barriers, or insulating materials to protect from shock, burns, or other electrical related injuries. Always guard exposed live parts. This protects an unqualified person from contact when maintenance or repair exposes them. There are many types of electrical safety equipment, protective apparel, and protective tools. So you have voltage-rated tools, tested rubber protective equipment, including gloves, sleeves, and blankets, arc-rated apparel, natural fiber clothing for underlayers, electrical hot sticks, fuse pullers, footwear designed to protect against electrical hazards, safety glasses, face shields, and switching hoods, hard hats, hearing protection. All of those to protect the worker. 2.2.0, selecting and using electrical safety equipment. Here's a highlight. It says Class E hard hats have the highest rating and are tested to withstand 20,000 volts of AC for a period of 3 minutes. So we as electricians want a Class E hard hat. E for electrical, Class E. The other electrical rated hard hat that is a Class G, it's a G for general. The Class G hard hat is tested to withstand 2200 volts AC for 1 minute. Class E and G climbing style hard hats are also available. These hard hats can be equipped with eye protection, rated face shields, chin straps, lights, and ear protection. So, ozone is a form of oxygen produced from an electrical field. It's in the air surrounding a conductor with high voltages. Normally you find ozone at voltages of 10,000 volts and higher, voltages that are in electric utility transmission and distribution lines. Warning: rubber protective equipment must be used, stored, inspected, and tested properly. Serious injury or death could occur if it fails during use. With electric gloves, safety harnesses, things of that nature, you don't put them in the tool box with other tools. You'll have a big job box where all the tools, the circular saws, hand saws, personal tools, screwdrivers, clines, what have you, hammers, all of those go in the job box. The rubber gloves do not. The safety harnesses do not. They have to be stored separately, hung up, so that they're not having things thrown in on top of them that could possibly damage the rubber glove or the webbing of the safety harness. It's a violation if OSHA comes out and inspects your job site. Types of rubber protective equipment. Type 1 rubber protective equipment manufactured from properly vulcanized natural or synthetic rubber. Type 2 ozone resistant equipment made from an elastomer or combination of elastomeric compounds. Type 2 rubber protective equipment is very stiff. It's not as easily worn as Type 1 equipment. Okay. Case history. I don't always like reading these. An electrician in Louisville, Kentucky was clearing a high voltage switch cabinet. He removed the padlock, securing the switch enclosure, and opened the door. He used a voltage meter to check the absence of voltage on the 3 load phases at the rear of the cabinet. However, he did not test all potentially energized parts within the cabinet. Some components were still energized. He was wearing standard work boots and safety glasses. He was not wearing protective rubber gloves or arc-rated apparel. As he used a paintbrush to clean the switch, an arc blast occurred. This lasted about 1/60th of a second. The electrician was knocked down by the blast. He suffered third-degree burns and required skin grafts on his arms and hands. The investigation determined that the blast was caused by debris such as a cobweb falling across the open switch. Bottom line, always wear the appropriate personal protective equipment. Always check up-to-date drawings and one-line diagrams so you know if there's additional power sources. Always test all the components for the absence of voltage before working on or around electrical devices. 2.2.1 Classes of protective equipment. Basically, Class 0 has a red tag. It's good for 1,000 volts AC or 1,500 volts DC. Class 1 is a white tag. Class 2 is a yellow tag. Class 3 is a green tag. Class 4 is the highest rating. It's an orange tag. It's good for up to 36,000 volts AC. All rubber protective equipment must be marked with the appropriate voltage rating and at least inspection date, the last inspection date or due date for retesting. This must be done before personnel in the field are allowed to wear the protective equipment. You also have to test the equipment daily before each use. So even if it's been tagged and it says, yes, this is past our inspection, anything could have happened. You need to test it, make sure that it holds air, make sure that it doesn't deflate, because if it has a tear in it, it's a potential for an electrical shock or electrocution. Okay. 2.2.2 rubber gloves. Voltage rated rubber gloves are the gauntlet type and come in various sizes. For the best possible protection and service life, observe these general guidelines considerations when using rubber gloves. Always wear leather protectors over your rubber gloves. Always wear rubber gloves right side out. Always keep the gauntlets up. Rolling them down sacrifices a valuable area of protection. Always inspect and field check gloves before using them. Always check the inside for any debris. Use light amounts of manufactured approved glove dust or cotton liners with the rubber gloves. This helps to absorb some of the perspiration that can damage the gloves over years of use. Wash the rubber gloves in lukewarm, clean, fresh water after each use. Dry the gloves inside and out before returning them to storage. Never use any type of cleaner. Store rubber gloves in a cool, dry, dark place that's free from ozone, chemicals, oils, solvents, or other materials that can damage the gloves. Be sure the gloves do not come into contact with chemicals, especially petroleum-based products such as oils, gasolines, hydraulic fluid inhibitors, hand creams, pastes, or salves. So you should never wear hand cream if you're wearing rubber gloves. These can damage the gloves. Wipe the contaminant off immediately if contact is made. Do not use the protective equipment if any signs of physical damage or chemical deterioration are found. Never wear watches or rings while wearing rubber gloves. This can cause damage from the inside and defeats the purpose of using the rubber gloves. Rubber gloves must be electrically tested every 6 months by a certified testing laboratory. Okay. Every 6 months by a certified testing laboratory. That's a highlight. Use rubber gloves only for their intended purpose. Do not use rubber gloves for handling chemicals or other work. This also applies to the leather protectors. Inspecting and testing the gloves. To perform a visual inspection, stretch a small area of the glove. Check to see that no defects exist. Defects could include embedded foreign materials, deep scratches, pinholes, punctures, snags, or cuts. Okay. So it says, as shown in figure 12A, verify the inspection date and voltage rating, 2500 volts. Okay. Visually inspect the glove. Trap air inside by squeezing and rolling the wrist portion of the glove. So here's the wrist portion of the glove. You trap air inside the glove, and then you continue to compress it so that it blows up the fingers. Listen and feel for escaping air. With air trapped inside the glove, squeeze it to expose any cracks, cuts, or defects, and hold the glove up to your ear to detect any leaking air. It's very important not to leave the rubber protective equipment inside out. Doing so places stress on the performed rubber. Okay, you can also inspect gloves with a glove inflator. Glove inflators offer the advantage of more precise field testing. To use a glove inflator, secure the glove to the housing using a nylon strap. Inflate it by pumping the bellows of the inflator against a firm surface, then check for leaks in the inflated gloves. So here is a bellows type glove inflator. Caution, never use compressed gas for the air test or inflate gloves beyond the manufacturer's recommendation. This can damage the gloves. 2.2.5 hot sticks. A hot stick is a handheld insulated tool designed for disconnecting and connecting switches, removing and inserting fuses, and applying and removing temporary grounds. So here's a hot stick. This guy is in his PPE. He's got his rubber gloves and his gauntlets, his leather gauntlets over it. He's got his hot stick, and he's either connecting or disconnecting the fuse. I'm not sure. I can't see the state of the other two, so I'm not sure if he's connecting or disconnecting. This is the fuse right here. So if you wanted to open it, there's usually a ring. There's the ring at top. You grab that ring and pull down it. There's a good example of the ring. There's the ring. You grab it with the hook and you pull it out. You disconnect it. Hot sticks have two parts, the head of the hood and the insulating rod. The head is usually made of either metal or hardened plastic. The insulating section is made of wood, plastic, laminated wood, or other effective insulating materials. Be sure to select a stick of the correct type and size for the application. When storing hot sticks, hang them up vertically on a wall to prevent any damage. Based on OSHA 1910.269J2I, each live line tool must be wiped clean and inspected for defects before each use. Live line tools must be removed from service every 2 years and tested in accordance with OSHA 1910.269J23. Fuse pullers. Use the plastic or fiberglass style fuse puller for removing and installing low voltage cartridge fuses. Always wear the proper personal protective equipment when using a handheld fuse puller. Discharge probes. You need to use safety measures before you start working on de-energized circuits with capacitors installed. You must first discharge the capacitors using a safety discharge probe. Eye, face, and hearing protection 2.2.8, NFPA 70E, and OSHA require that you wear safety glasses at all times whenever working on or near energized circuits. You also need to wear an arc flash shield over your safety glasses. Be sure to wear it whenever there's danger of electric arcs or flashes. You'll also need it when there is a danger of flying or falling objects resulting from an electrical explosion. Decibel. The decibel level of a typical arc blast can reach well above 140 decibels. For comparison, that's similar to the decibel level of a fully throttled jet engine just 100 feet away. Without wearing protection, the hearing damage from the arc blast can be painful and irreversible. Always wear hearing protection when working on or near an energized circuit. And here he is using a phasing tester. Section 2.0.0, section review. Periodic inspection and testing of protective equipment is required by OSHA. Rubber protective equipment with a white tag is rated for, look back on that chart, I believe it's 7,500 volts AC. This concludes the section 2. I'll see you on the next video.